Hello everyone, in this video we'll be solving problem 1161 maximum level sum of a binary tree. We are given a root of a binary tree and we need to return the smallest level x such that the sum of all of the values of the node at that level is maximum. The binary tree in example number 1 have 3 levels. The first level have only one node with total of 1 and the second level we have two nodes 7 and 0 giving us the total of 7, and in the third level we have two nodes 7 and minus 8 giving us the total of minus 1. As 7 is the highest amongst all three values, we'll return its corresponding level, which is 2. I hope you are able to understand the problem statement. Now let's switch to whiteboard and discuss how we can solve this. There are two algorithms or techniques using which we can traverse through a binary tree. One is the BFS, breadth first search, and the other is DFS, that is depth first search. Depending on the requirement, we can choose the appropriate algorithm to solve the problem efficiently. As we need to calculate the maximum sum of all of the nodes across a single level or a breadth, using BFS would be ideal. It is also possible to solve the very same problem using DFS, but BFS is more suitable here as it allows us to calculate the sum at each level. Q is the most commonly used data structure whenever we do BFS as it supports first in first out operations. The solution starts by adding the root node to the queue and then starting a while loop to monitor the queue until it is not empty. All of the nodes in the queue are expected to be at the same level. So we run a simple for loop on all of the nodes, calculate its value, sum them up, and that will give us the total sum of all of the nodes at the given level. As we are looking for the maximum sum, we'll compare the current sum with the maximum sum variable and the higher value will be saved into the global variable. After processing the node, it should be removed from the queue and its children should be added to the queue if there are any. In this case, 7 and 2 will be added to the queue and 1 will be removed. We'll repeat the same operation again, but this time it will be much cleaner because we have multiple values in the queue. So adding all of the nodes will give us a total of 9, which is greater than the current maximum sum, so the value will be overridden. Both nodes 7 and 2 have a child node 7 and minus 8, so both of those should be added to the queue while we remove 7 and 2. This cycle will continue until we have iterated through all of the nodes in the given binary tree. As 7 and minus 8 are leaf nodes, it does not contain any children. So after processing these nodes and removing them from the queue will be empty. And an empty queue is a sign that we have iterated through all nodes and we can return the output. As we need to return the corresponding level where we calculated the maximum sum, we'll be using a separate variable to record or keep track of the level where we found the maximum sum. So in this case, the level is going to be 2, which is our output. With this solution, our time complexity is O of n, where n is the number of nodes in the given binary tree. It is clear why it is O of n, as we are iterating through all of the nodes once to calculate the sum. While the space complexity is O of n as well, as we are using a collection queue to record the total number of nodes at each level to calculate the sum. I hope the explanation was helpful. Let me show you how we can implement this using CSharp. In this CSharp implementation, I start by adding a validation to make sure that the root node is not null. Next step is to initialize our queue and add the root node to it. Next step is to start a while loop until the queue is not empty. Inside the while loop, I'm using the for loop to iterate through all of the elements in the given queue to calculate the total sum. This sum will represent the sum of all of the nodes at a given level. Basically, I'm removing the top element from the queue, taking its corresponding value and adding it to the current sum variable. If the current node has any children, those will be added again to the queue at the end so that it can be processed in the next cycle. After the for loop is complete, I am comparing the current sum with the best sum, and if it is higher, then it will replace the current value and the best level will also be set to the current level. Once the queue is empty, we'll jump out of the while loop and return best level as the output. This code, when submitted on LeetCode, beats nearly 70% of the submissions in terms of runtime and nearly 54% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.